You got one of the first.
Okay, can everybody settle down so we can finish our...
Michael Kors.
Yeah, be more careful next time.
Alright, you guys are used to plotting points on the Cartesian plane. X and Y. Now, what is X? X is how far you go this way, right?
Correct.
And Y is how much you go down. This is
Yes.
X and this is Y.
Oh, you're killing me.
But is that the only way we can locate points in the Cartesian plane? And the answer is no. So we have another coordinate system. It's called the polar coordinate system. So in the rectangular coordinate system, you have X and Y. But in the polar coordinate system, we have R and theta.
Oh, it's like you go out a certain distance R and then you theta.
So here, let me just tell you what it is. R represents how far you are from the origin. Okay? But in the polar coordinate system, we call that the pole. We call the origin the pole. But if you call it the origin, it's fine. And theta is the angle right there. At this radius, I guess you can call it a radius if you want, makes with the positive x-axis. So what you have to do tonight is you have to plot points in the Cartesian plane that are polar coordinates. Now you might be wondering, Mr. Park, why does the polar graph paper look like that? Look at the polar graph paper. Well, when you were in Algebra 1, you know when you were first given graph paper, wasn't it just all these little lines like this? Graph paper, like this?
Yeah.
You know why? Because if you have to plot the point 3, 2, then here's the origin. You go 3 to the right and 2 up. It's easy to do if you make the grids like that. But in the polar coordinate system, if you look at the graph paper there, that's on the website. If I were you, I would go when I go home, print out like several of these.
Have them ready.
Because you know when you do your homework, you can, if you want to, you can do one on each one. But if I were you, I'd put like 5 or 6 on each one.
What?
Just do different colors.
Oh.
Or whatever, or like put the number on it or something. Notice that there's all these concentric circles like this. Oh, that's pretty good. No, it's not. And then you got these angles measured off like this, yeah? You guys notice I got all these angles there? Basically, they have one for every 15 degrees like this. Now, notice that two of them I gave you in degrees, and the other 2 are in radians, because maybe that'll actually help you with your unit circle. So, how do we do polar coordinates? Like, how do you plot the point, for example, 345 degrees?
What?
So again, what does R represent? R represents how far you are from the origin, or the pole. Theta is this angle here. So, when you plot polar points, what does this mean? You're 3 units away from the origin, and you're making an angle of 45 degrees.
Wait, so is each
And
like the small circles 1 unit? Then?
Exactly.
Oh,
Okay, so when I graph polar coordinates, I like to graph the theta first, measure off the angle first. So remember, we always start here, this is 0, and if it's positive, counterclockwise, right? If this angle is negative, you go clockwise, just like when we learned a unit circle. So from here, I go 45 degrees counterclockwise, so that would be here, 45 degrees, and then you go 3 units from the origin. So here's origin, then you just go 1, 2, 3. See, that's why you have all these concentric circles, because then it's easy to count how far you are from the origin. So that's why polar graph paper looks like this. Now this is pretty ugly, this picture. Is there a way I can plot points on that thing right there?
Yep. Yeah, use a
Oh.
pen. Yeah, then put on your iPad.
Just
Use a
Okay.
pen.
use the marker.
I'm not gonna do it. No, sit down. We're just gonna do it on this ugly thing here. Okay, let's do some more. So tonight's homework, all you gotta do is plot points. But then, after tonight, can you see what's gonna happen though?
I just go home, cook rice.
Yeah.
That's the thing.
What did we do in Algebra 1? Think about it. Think back to Algebra 1 or pre-Algebra when you first learned to start, when you plotted points.
Make lines.
Yeah, you drew graphs. And that's what we're going to do next. We're going to draw graphs. Got some really neat graphs you can draw in the polar coordinates. Okay, let's do some more. How about, let's do some more. Let's do some, put in some radians over there. How about 4 comma 2 pi over 3?
Easy money.
Now 2 pi over 3, now if you need to convert it to degrees, do whatever you have to at this stage already. Like, are you guys used to radians? Then you would know that 2 pi over 3 is like right there, yeah? 120 degrees. And then you just go 4 units from the origin. So 1, 2, 3, 4, wait. 1, 2, 3, 4, there you go. Plot the point. That's all you gotta do tonight. Just plot points. This is so easy. Okay, let's do another one. How about 2 comma 7 pi over 6? Do another radian one. Now, where is 7 pi over 6? That's an angle of 210 degrees. That's like over here, right? See, it's all labeled on the polar graph paper, so it's easy for you. And then you go 2 units from the origin. 1, 2. So it's right there. Oh. Okay, let's do one with degrees again. How about 5 comma 270 degrees?
Oh,
So you measure off, so from here, you go 270 degrees counterclockwise. So that's down here, right? 270 degrees. And then you just go 5 units from the origin. 1, 2, 3, 4, 5. Like that. Now, it's very easy to plot when r is positive and the angle is also positive, but these things don't have to be positive now. These can be negative. So what if you have the point for negative 60 degrees? Oh, what does negative 60
Or
degrees
you go
mean?
clockwise.
That means from here, you go 60 degrees clockwise. So that would be here, right? And then you go 4 units from the origin. 1, 2, 3, 4.
Isn't that like the same as going like 200 or 300?
Exactly. Okay, we're getting to that. Okay. Did you guys hear what DeMello said?
Yeah.
Hey, looking back, why don't we take care of that right now? Mr. Park, isn't that the same thing as 4 comma 300 degrees?
Yes, Mr. Park.
So from here, what if I go 300 degrees counterclockwise? Yeah. That's right there. And then you go 4 units from the origin. 1, 2, 3, 4. That's the same place. That's right. So you just learned that in a polar coordinate system, a point can be labeled in an infinite number of ways. You could have this, you could have that, you could also have 4 comma. What if I went like this?
299 plus 1.
what?
Yeah.
No. 660
Oh,
degrees.
yeah.
See, because look, here's 300 degrees. What would happen if I go around the circle one more time? Isn't that another 360 degrees? Okay, then you could also do this then. 4 comma, just keep adding 360 degrees. Add 360 to that.
1020.
1020. So yes. So for every point in the Cartesian plane, there's an infinite number of ways of labeling. But the most common way is this one right here. R is positive, and that angle is between 0 and 360. That would be the most common. Okay, so you guys know how to handle negative angles, right? I think we better do another one. What about 5, that's not 5, 5 negative, let's do some radians. Negative what?
5 pi over 4.
Negative 5 pi over 4. I like that. Okay, measure off an angle of negative 5 pi over 4. That means from here, you have to go 5 pi over 4 clockwise. So, is it right here?
Yeah.
Right there? And then you go 5 units from the origin. So, 1, 2, 3, 4, 5. Can do? Okay, now this is where students get confused. What happens when r is negative?
You go the
Exactly, you go the opposite direction. So let's do one. How about, let's do an easy one. How about negative 3, 30 degrees?
So you go
So
30
from
degrees.
here, you measure off 30 degrees.
It's on the bottom, yeah?
That would be right here. And then you have to go 3 units in the opposite direction. So 30 degrees is like this, right there. So if I were to go 3 units in the opposite direction, that would be right here. 1, 2, 3. So when r is negative, you have to go in the opposite direction of that angle. You guys get it? No, I don't think so. We gotta do one more. Huh? Yeah. What? You get it?
Spark.
Oh, so you think you're good? You think you're better than me? Spider web. What does that have to do with this?
Same thing.
I don't think so. How? You guys are so sad. That's what this is.
Same thing, dude.
Okay, how about -4, 75 degrees? Let's just go 75 degrees. Mr. Park, 75 degrees, where's that?
Between
Well,
90 and 60?
so I go 75 degrees counterclockwise, so that would be right here, right? 15 degrees short of 90, right? And then I gotta go 4 units in the opposite direction, so that would be going down here, 1, 2, 3, 4. Now, my drawing is like pretty ugly, but when you do it on the graph paper, it's easy because everything is right there. Now, what would happen if both of them are negative? What if both of them are negative? Like, what if you had -3 -pi/2? Is that gonna pose a problem for you?
No.
No. So again, I like to do the angle part first. So measure off an angle of pi/2, which is 90 degrees, clockwise. So that would be right down here. And then you gotta go 3 units in the opposite direction. So 1, 2, 3, be right there. See, so you could do like the entire homework with just like one of these. See how I labeled on, and then you can label like, okay, this was number 1, this was number 2, this was number 3, or 4, like that. Instead of just doing 1 point for each one.
How many problems are on tonight?
Okay, but some of tonight's homework, you're gonna have to like plot the points. Other homework, the other part of the homework is they're gonna give you a point and they're gonna ask you to label it in a different way. So, for example, this point right here, -3, -pi/2. So you measure off this and then 3 units in the opposite direction. That's this point right here. Okay, I'll point to it right there. What's another way of labeling that point?
Okay, bring in the negatives.
So you could go what? You could go 90 degrees and then 3, right? So that's another way to do it.
Can you just get rid of the negatives?
No, you gotta,
They want you to change
gotta
one
think,
of the numbers.
you gotta think.
Okay.
Or, what's another way to label this point here? How about 3 and then add 360 degrees to that? So 450 degrees. So there's lots of ways, there's an infinite number of ways of labeling that point. So then they're gonna ask you all these different ways of doing it. You guys can handle that, right? Okay, so tonight's homework is easy. All you have to do is like plot points and change the coordinates. Okay, tomorrow what's gonna happen is, do we have class tomorrow or Monday? I'm gonna give you polar coordinates and then you gotta convert it to rectangular coordinates.
Cool.
And then I'm gonna give you rectangular coordinates, then you gotta convert it to polar. So you have to be able to convert back and forth. It's not that hard either. But then, after that, then we're gonna start drawing graphs. Then it's gonna get a little more challenging. Do you guys ever graph? Here, you know what? I just wanna show you something. I'm gonna bring up my graphic calculator so you can see. This is just to show you what we're gonna learn.
Are we gonna be able to use a graphic calculator?
Except, you're gonna graph it by hand. You're not gonna have a calculator to graph by hand. So we have to go into graph mode. How are we gonna do that? Menu, go to graph mode, and then type. We want, okay, what's going on? Type. There, we want R equal. What's happening? That's because I didn't get rid of these. How do you delete? Okay, F2. Stop telling me what to do. F2. I already said yes. Come down one. Delete F1. Okay, there you go. You want to see a pretty graph that you guys are going to draw? Hey. Stop laughing. How come you can graph? Oh, you can graph plenty graphs at once on this calculator. Gosh darn this thing! No, I want to go up to R1.
You gotta be patient.
gonna hurt this calculator.
Kick it. The high kick.
Hey!
The park high
Okay,
kick.
there. Okay, watch this, watch this. You guys wanna see a neat graph? Watch this. R1. So what we gotta do, we gotta punch it in. How about 3 sine? How about, I'm trying to concentrate. 6 theta. Woohoo!
It's a flower.
Yeah, it's a flower. That's the kind of graphs you're gonna draw.
Draw?
Yeah, you're gonna actually draw it by hand.
Oh,
Okay, but the thing doesn't look
can't draw.
circular. I'm gonna go B window square. I like that.
Is drawing one.
That didn't do anything! B window.
I'm the only one that heard.
Okay, let's try that. There you go. Now it looks like See that?
Yay!
Sunflower.
So you know what's gonna, but you don't, I gotta teach you stuff, but see what's gonna happen is I'm gonna give you that graph, and then you're gonna have to write the equation.
Are we gonna have to plot something like that? Like,
Yeah.
give us the equation
Yeah.
and draw that?
So, yeah, okay. It's gonna be very interesting.
I'm on a roll today.
And you might be wondering, why are we learning this, Mr. Park? Just so teachers have jobs?
Yeah.
Yeah.
No, because there's applications of this.
Why did you use this in real life?
Okay, of all the math that you learn up through your college career, what percent do you think you're gonna actually use in real life?
100%.
No.
1%.
Well, I'll tell you right now, engineers use less than 10% of the math. That's engineers now. So just like normal people, what percent of the math you learned?
2%?
3.
1.
Yeah, it's like probably 1% or less.
What are you talking about?
You're not helping her more.
All you have to know in real life is just addition and subtraction, right? So you can balance your checkbook.
Or multiplication.
No, you don't even need multiplication.
Learn that. We have calculators.
Yeah, but you gotta know when to add and when to subtract, right?